Hello and welcome to Everyday English AI. Today, we are going to talk about a topic that sounds very futuristic, but is becoming a reality in 2025. That topic is quantum computing. Maybe you've heard this word in the news, in tech videos, or on science websites. But what does it really mean? Why are countries and big companies spending millions on it? And most importantly, how can we understand it in simple English? That's exactly what we'll do in this video. Let's begin. Section 1. What is quantum computing? Let's start with the basics. To understand quantum computing, first we must understand how a normal computer works. A traditional computer uses something called bits. A bit is the smallest piece of data. It can only be 0 or 1. That's all. Every photo, video, game, or email you see is made from thousands or millions of zeros and ones. That's called binary code now. Quantum computing is different. Quantum computers use something called qubits, short for quantum bits. A qubit can be 0, 1, or both at the same time. This idea that something can be in two states at once is called superposition. Let's use an example. Imagine flipping a coin. A regular computer is like a coin that is either heads or tails, but a qubit is like a spinning coin. It can be heads, tails, or both at once, until it lands. This is what gives quantum computers their power. They can process many possibilities at once. Section 2. How does it work? Quantum computers are built very differently from regular computers. They use special materials, ultra-cold temperatures, controlled environments. Why? Because qubits are very sensitive. Even a small noise, heat, or vibration can destroy the quantum state. That's why quantum computers often operate at near absolute zero. That's about minus 273 degrees Celsius. They are kept in large metal machines, almost like refrigerators. Now, let's go deeper into two key ideas. 1. Superposition. As we said earlier, a qubit can be both 0 and 1 at once. This allows a quantum computer to explore many answers at the same time. 2. Entanglement. This is when two qubits are linked together, even if they are far apart. Changing one qubit instantly affects the other. Einstein called this spooky action. At a distance, these features allow quantum computers to solve complex problems faster than normal computers. Section 3. Why does it matter in 2025? Now, let's answer an important question. Why is quantum computing so important in 2025? Here's why. Governments, tech companies, and universities are investing heavily in this technology. For example, the UK government is investing over £500 million into quantum research. India is working on quantum internet for safer communication. Microsoft recently developed a special chip for quantum computing called Majorana 1. IBM and Google are racing to build more powerful quantum machines. Why? Because quantum computing can solve problems that regular computers cannot, or would take thousands of years to solve. It's not just about speed. It's about solving impossible challenges in medicine, space, finance, and more. Section 4. Real-world examples of quantum computing. Let's look at some real-world examples where quantum computers are already being used or tested. Healthcare and medicine. Quantum computers can simulate molecules and chemical reactions. This helps scientists design better medicines faster. Instead of testing thousands of combinations in the lab, quantum computers can simulate them in seconds. Example 2. Artificial intelligence, AI, and machine learning can use quantum computers to learn patterns faster. This can lead to smarter robots, better language models, and faster translation tools. Example 3. Finance and banking banks use quantum computing to study financial risk. It can help find the best ways to invest money or predict stock prices. Example 4. Climate. Modeling quantum computers can study weather, oceans, and ecosystems with great detail. This helps scientists understand climate change and plan for disasters. Example 5. Cybersecurity. Quantum computers may break current internet security systems, but they can also create new, unbreakable security methods through something called quantum cryptography. These are just a few examples of how quantum computing could change our world. Section 5. What are the challenges? Now let's talk about some problems. Even though quantum computing is powerful, it still has many challenges. Problem 1. Error correction. Qubits are not perfect. They make mistakes easily. Scientists are still learning how to fix these mistakes. This is called quantum error correction. Problem 2. Stability. Qubits are hard to control. If they are disturbed even a little, they lose their quantum state. Problem 3. Cost. Quantum computers are very expensive to build and run. Only governments and large companies can afford them today. Problem 4. Commercial use. Right now, most quantum computers are used in research. We may need 3 to 5 more years before businesses can use them every day. So, while the technology is exciting, it's still in the early stages. Section 6. What can you do? As a learner, even if you're not a scientist, there are simple things you can do to get involved. Here are 4 ideas. 1. Learn the basics. Know what a qubit is. Understand terms like superposition, entanglement, and quantum error correction. 2. Try quantum tools online. Companies like IBM offer free websites where you can run simple quantum programs. You don't need to install anything. It runs in the cloud. 3. Follow quantum news. Stay updated with new discoveries. Read simple articles or watch explicable videos like this one. 4. Build your science and English skills together. Learning new tech terms in English helps you join global conversations in jobs, in school, or in social media. You don't need to become a quantum scientist, but understanding the basics helps you be part of the future. Section 7. Vocabulary review. Repeat after me. Let's now review some important English words from this video. Repeat slowly after me. Bit, the smallest unit of data in a computer's 0 or 1 qubit. A quantum bit can be 0, 1, or both. Superposition, being in 2 states at once. Entanglement, when 2 qubits affect each other, even far apart. Simulation, copying or modeling. Something digitally. Error correction, fixing mistakes in a system. Cryptography, writing or solving secret codes. Quantum, related to tiny particles of energy and matter. Unbreakable, something that cannot be broken or hacked. Fragile, easy to break or damage. Asterisk, quantum computing is a powerful new idea. It is already helping scientists, doctors, and engineers in 2025. It may still take years before we see it in daily life, but now you understand it. You know the key words, the big ideas, and the real-life uses. You've learned science and improved your English. At the same time, thanks for watching Everyday English AI. If this video helped you, please like, share, and subscribe for more. Tell us in the comments, which part of quantum computing was most interesting to you. See you next time.